Notes 2.4, we're going to talk about absolute value equations. We know that the absolute value makes everything positive, and it looks like a V when you graph it. Those are some things we know about. It's also a type of piecewise function. We're going to get more with piecewise in our next lesson, but you can think of it as this. It's the same thing as y is equal to negative x for part of it. That's the equation y equals negative x. Has a y-intercept of 0 and a slope of negative 1. And another for x equals, for y equals x for over here. Okay? And this was for our f if our x is less than 0. And this is for our x's that are greater than 0. So on these x's over here, if we plug them into here, so say I have a negative 2, right? So negative 2 makes it a positive 2, makes it that positive number. Okay, so you can think of it in that way as well. We'll talk more about piecewise functions our next block. Some different properties of absolute value. We have absolute value of a times b is the same as the absolute value of a times the absolute value of b. Same thing for divide. Absolute value of a divided by b is the same as absolute value of a divided by the absolute value of b. And absolute value is equal to the negative of the absolute value because it makes it positive. Also, if you have absolute value plus the absolute value of b, that's always going to be greater than or equal to the absolute value of a plus b, like this. Okay? Just some things to think through. Plug some numbers into those and see if they make sense to you as you do them. Okay, if I look at this graph, you start at negative 1, and your slopes as you go up 2 over 1. Okay, so our graph of this one would look something like this. Now, how does that look versus this? Okay, well, basically, you know, we have a x-intercept here, right? So it's the same x-intercept, but it just reflects it up. It reflects this part up because I can't have negative answers, right? My outputs can't be negative. So it just takes the ones that turn to be negative and flips it up to be positive then. Okay? Now, the rest of the time here, we're pretty much going to be solving these absolute values. Analytically, you know that absolute value can be either positive or negative. So when we set this up and solve this, we're going to say that 2x plus 1 could either equal 7, right? So if I have the absolute value of 7, that would equal 7. Or this 2x plus 1, if this comes out to be a negative 7, the absolute value of negative 7 is also equal to 7. So I could also have that equal to negative 7. Okay? Then I just solve them. Subtract your 1. So 2x equals 6. Divide gives you x equals 3. Subtract your 1. And divide by 2, you get negative 4. So we get two different answers most of the time. Okay, let's see how that works when you plug it back in. Plug in a 3. 2 times 3 is 6. 6 plus 1 is 7. Absolute value of 7 is equal to 7. Plug in a negative 4. Take a guess what you're going to get. 2 times negative 4 is negative 8. Plus 1 is negative 7. Absolute value of negative 7 is also equal to 7. Okay? Graphically, you could graph this part here, which is a V that looks something like this. And y equals 7 is another graph that looks like this. And your solution is where they cross each other. Okay? So in this particular problem, it'll cross over at x of negative 4 and of x of 3. So you can see where those two solutions are there if you want to do it graphically as well. Okay. Most of these other ones here are going to be less than, greater than. We have a sum or equal to as well here. Let's do all the or equal to first. Okay, so once again, always remember to set up your two equations. 4 minus 3x is equal to 2, and 4x minus 3x is equal to negative 2. Okay, so when you solve it, subtract your 4 over. Actually, go ahead and solve it yourself. Pause it and solve it. Make sure you got it. That's not a 4x, that's just a 4. Subtract it over and divide. Okay, so you got your two answers. Okay, and you can take them and plug them back in and make sure they work. Okay, now this one, hopefully you notice something right away, but let's think about this. If we just think about this, can an absolute value, if I take the absolute value of some number, can it equal a negative 15? Okay, nope, because absolute values always makes it positive, right? So we would see that there is no solution to this. Okay, if you would work it out, equals negative 15 and equals positive 15. When you take those answers and plug them back in, they won't work. So you can see that there would be no solution. But hopefully you realize when you see absolute value equal to a negative number, there's no solution to it. Okay. Now, equals with two different absolutes, we have to do this x plus 6 could either equal 2x minus 3, or our x plus 6 could equal the opposite of this 2x minus 3. Okay, so those are how you set up the two things. Okay, then you solve it. I'm going to subtract that x over, and I'm going to add the 3 over, gives you 9. Okay, here I'm going to distribute through that negative, so negative 2x plus 3. I'm going to add the 2 over here, and subtract the 6 over there, and divide gives me negative 1. Now, you can check and make sure. This to make sure. Plug in a 9. 6 plus 9 is 15. 18 minus 3 is 15, so 15 is equal to 15. Plug in a negative 1. That and negative 1 give you 5. 2 times negative 1 gives you negative 2. Minus 3 is negative 5, but the absolute value of negative 5 is also equal to 5, so both of those answers work there. Okay. This one is very tough, and really what we would do is we would graph this. Okay, we're just going to use graphing for our techniques. So if you would put this into Desmos, this graph looks something like this, and then y equals 16 would look like this at 16. Okay, our solutions of where they cross have an x of negative 9 and have an x of 7. So those would be your two solutions here, that x equals negative 9 and 7. Okay. All right, now let's go to the less than greater than, the inequalities here with the absolute value. Okay, we're still going to set up two equations. Okay, let's think. I'm just gonna do a side note problem here. Okay, so we want to know what numbers are greater than 2 away from. So the absolute value, the idea of absolute value is how far away is it from 0, right? So absolute value of negative 4 is 4 because it's 4 away from 0, right? Absolute value of 10 is 10 away from 0. So where are my numbers that are greater than 2 away from 0? So from 2 or more, right? Those would be greater than or equal to. Or these numbers here are also more than 2 away from 0, okay? So in doing this, when we set up our two equations, with this one, you would say that x is greater than the 2. You would also say that x is less than the negative 2. Okay, so see, when you set up the negative sign, you have to flip that sign around. Okay, so one equation would be 2x plus 1 is greater than 7. The other equation is you have to flip this sign around when you make it that negative 7. Okay. Now, we also have one other little thing here. We have to tell if this is an and or an or statement. Okay. You can think go LA. I'm not a LA fan at all, but you can think go LA or land of Gore. Okay. So basically, this is a greater than. So if it's a greater than, it's an or statement. Greater than is an or statement. If it'd be a less than, okay, a less than would be an and statement. Less than is an and statement. Okay, now what's the difference between an and or? Basically this. Say I have this graph, right? Say I have 1 and 2. Are there any numbers that are less than 1 and greater than 2? Are there any numbers that fit both of those, that are less than this and greater than this? No. Okay, but as an or, are there numbers that are less than 1 or greater than 2? Yeah. All the ones that are less than 1 and all the ones, right? All these and all these work for that. Okay? And conversely, if you have the graphs coming together, Okay, let's just say this is 5 and 10. Okay, so if this is an or statement, what numbers are greater than 5 or less than 10? Well, all these numbers are greater than 5. All these numbers are less than 10. So if I pick a number out here, does it fit one or the other? Yeah, it's less than 10, right? So if it's an or, I would have all real numbers. Okay, as an and statement, both have to be true. So what numbers fit both of those? All the numbers between 5 and 10. Okay, that's the difference between the and the or. So how we interpret our answer at the end will be the thing. Okay, so getting back to this problem. So to solve it, I'm going to subtract the 1 over and divide by 2. And subtract the 1 over and divide by 2. So when I look at this graph, my -4 is my lower number, upper number is 3. My numbers are greater than 3, and my numbers are less than -4. Okay? Now, since this is an or statement, I know that all these numbers or all these numbers work. That would be my solution. Okay? This one here, my two equations, 2x plus 1 is less than 7, and because it's less than, right? Less than is and. 2x plus 1, switch a sign and make it negative. So you solve it out, subtract the 1 and divide. Subtract your 1 and divide. Okay, so if we look at this graph, greater than -4, so my numbers that are greater than -4, and my numbers that are less than 3. Okay, now, since this is an and statement, where is it true for both of those? Well, any number in between here will be less than 3 and greater than -4. If I pick a number down here, it'll be less than 3, but it's not greater than -4. And if I pick a number up here, like 5, it'll be greater than -4, but it's not less than 3. So as an and statement, it has to be those numbers in between there. Okay? Pause it and try these by yourself, and then unpause it and come back. Okay, so we have one equation as it is, and we have the other equation where we flip the sign and make it a negative. Okay? And it's a greater than. Think go LA, right? Greater than is an or, and then you just solve it. So subtract your 4 over, and remember when you divide by a negative number, you switch that sign around, just like you did back in Algebra 1. Okay, and here, whoops, that's a 4, not a 4x. Here I'm going to subtract that 4 over and divide by a -3. When I divide by a negative, I got to flip that sign around. Okay, so I get 2. So looking at this graph, 2/3 is lower and the 2 is higher. So greater than 2 or equal to, so filled in circle, and filled in circle x is less than that. Okay, now, since this is an or statement, we have all these numbers or all these numbers, which would be our solution. So if I asked you to pick 3 numbers that were solutions, you could pick 2, 3, 4, 5, 6, 7, right? You could pick 0, -1, -2, -3, but you couldn't pick any numbers in between there that would work. Okay, next one, once again, 4 minus 3x is less than or equal to 2, and 4 minus 3x is greater than or equal to -2. And since it's a less than is going to be an and statement. And once again, solve it, subtract the 4 over, divide by a negative, flips the sign around. Subtract the 4 over and divide, flipping this sign around. Okay. So we have 2/3 is less and 2 is more. It's less than or equal to 2. And it's greater than this one. So where does it fit both of them as an and statement? All those numbers in between there. Okay. Now, we're going to get into some special cases right here with these two. So pay close attention here. So once again, set it up as it is. And less than is going to be an and. Flip the sign and the opposite of what's there. And you solve it. Add, subtract the 5 over. And divide gives you -10/3. Subtract your 5 over gives you 0, and divide gives you 0. Okay? So we have our negative 10/3 is down there somewhere, and 0 is up here. Has to be greater than 0, and has to be less than negative 10/3. Now, are there any numbers that you know of that are greater than 0 and at the same time less than negative 10/3? Nope, there aren't. So there's no solution to this problem. Okay. Now, another thing you could have noticed right away is an absolute value is a positive number. And if I have a positive number, can that be less than negative 5? Are there any positive numbers that are less than negative 5? Nope. So right away by looking at that, you could kind of see that there's no solution to it. Okay, the next one. So 3x plus 5 is greater than negative 5. So here, if I look at this, they're positive numbers, right? Are there positive numbers that are greater than negative 5? Yes, there are. Yep. How many and which ones? Okay, anyway, we'll get to that in a second. And it's greater than, so it's an or statement. So 3x plus 5, switch the sign and make the opposite of that sign there. Solve it. Subtract that over and divide. And subtract that over and divide. Okay, so if we look at this graph here, there's our negative 10/3, there's our 0. X has to be less than 0. X has to be greater than 10/3. Okay, so the ones that we've seen in the past like this have been all the answers here, right? But since this is an or statement, do these numbers down here work? Okay, are they either greater than this or less than 0? Yep, so those numbers are less than 0. And the numbers up here would work too. So in this case, every single number works. If you think about this, any positive number here is going to be greater than negative 5, right? Okay, so that's how you can think through that one. Okay, the last two. These get pretty complicated, and this is just for extension for you. I don't know if we'll do too many of these. But we would have this one. X plus 6 is less than 2x minus 3. We would also have that x plus 6, flip the sign, and equal to the negative of the 2x minus 3. And here's the tricky part. Think about this one as well, right? We have this one also has to be flip the sign equal to the negative of this one. So we have 3 scenarios. We have 1, 2, and we have to have a third then, where that 2x minus 3, flip the sign, is equal to the negative of the x plus 6. Okay, so it has to fit all 3 of those. So if I solve this, I'm going to subtract that x over, add that over, gives me 9. Okay, this would be negative 2x plus 3. And add that over, gives me 3x. Subtract that over, gives me negative 3. Divide gives me negative 1. Be negative 6x minus 6. And if I add this x over, it gives me 3x. Add that 3 over, gives me negative 3. Divide, it gives me this. Okay? So in this problem right here, we have negative 1 and 9. So it has to fit all these. Right, so x is greater than 9. Be a graph like this. X is greater than negative 1. Be like this. X is less than negative 1. Looks like this. Okay. Okay, so to decide where our answer is, we have to plug these in and see if the numbers work. So let's take a number down here. Let's take like negative 2. Okay, take negative 2 and plug it in. Negative 2 plus, okay, negative 2 plus 6 gives me 4. And negative 2 times 2 is negative 4, minus 3 is negative 7. Absolute value of negative 7 is 7. So is 4 less than 7? Yep. So these numbers will work down here. Okay, let's check above 9. So let's check like 10. So at 10 would be 16. And 20 minus would be 17. So is 16 less than 17? Yep. So that one works too. Let's check a number in between here. I don't know, like 0. Okay. 0 plus 6 is 6. and 0 would be 0 minus 3. Absolute value negative 3 would be 3. Is 6 less than 3? Nope. Okay, so our solution would be all those numbers less than negative 1 and greater than 9. Those would be our solutions. So if you write it as an interval notation, from negative infinity to negative 1 is a solution, and then from 9 through infinity is a solution as well. Okay? You could pause it and try this, or, okay. So x plus 6 greater than or equal to 2x minus 3. X plus 6, switch the sign, the negative of it. And the third scenario, that 2x minus 3, switch the sign and make the negative of it. Okay, so solve them out. I'm going to subtract that over, add that over. Distribute. I'm going to add that over here. I'm going to subtract that over there. Divide gives me negative 1 there. Okay, I'm going to add that over there and add the 3 over there and divide. Okay, so we have our negative 1 and our 9 again. Less than or equal to negative 1. Greater than or equal to 9. And greater than or equal to negative 1. I'm sorry, this is x is less than or equal to 9, not greater than, less than. Okay, so by looking at this, we have to check the 3 areas here, see if they work. So let's take negative 2. Okay, so negative 2 would be 4. Negative 2 would be 8, negative 8. No, sorry. Negative 2 would be negative 4, negative 7, absolute negative 7, 7. Is 4 greater than or equal to 7? No, it's not. Okay, so it won't work down here. Plug in a 2. Okay, be 8. And 4 minus 3 would be negative 1. Absolute value of negative 1 is 1. Okay, is 8 greater than or equal to 1? Yep. Okay, so it works for the numbers in between here. Pick a number like 10. 10 would be 16. And 20 minus 3 would be 17. Is 16 greater than 17 or equal to it? Nope. Okay. So our numbers, our solutions are all these numbers between 1 and 9. So between 1 and 9 would be our solution. Okay.